everyone. My name is Brayden, and I work towards researching how to effectively retrofit open water wetlands in Southern California to accurately measure flows. This project was funded by the Mines Undergraduate Research Fellowship, and I worked alongside Adam Brady, Laura Leonard, and Dr. Jonathan Sharp, who are part of the Department of Civil and Environmental Engineering at the Colorado School of Mines. So just some background, the Prado wetlands are a series of wetlands in Southern California that were designed to improve water quality for the Orange County Water District, and they do this by removing nitrates and other pollutants from the Santa Ana River and emptying it back into the river. So the problem lies within the plumbing and outflow. The current hydraulic gradient between the B cells and the downstream experimental wetland is too low, and that is inhibiting current accurate flow measurements for the researchers at Prado. The solution I came up with was a Weir box, and Weirs and Weir boxes are solutions that are used to control and accurately quantify open water channel flow, and I thought this would be a great way to mitigate the outflow issues that are occurring at Prado. So right here is an aerial view of the Prado wetlands, and these Weir boxes we place at the end of each of these 6 B cells pictured in the red rectangle, and the water from these wetlands would empty into this experimental wetland below. So I decided to go with a fully contracted 90-degree V-notch Weir for various reasons. So the first one was the ease of calculation. So below is an equation from the U.S. Bureau of Reclamation's Water Measurement Manual, and it is for a 90-degree V-notch Weir, which if you look down here, 90 degrees is this theta measurement of the notch. And Q, which is the water flow in cubic feet per second, equals 2.49 times H, which is the distance from the top of the water flow to the bottom of the notch to the power of 2.48. So this, along with the constraints, and the constraints of this equation and this type of Weir are that P, which is the distance from the bottom of the Weir to the bottom of the notch, has to be greater than 2 times the max height. S, which is the distance from the side of the Weir to the water line, has to be greater than 2 times the max height. As well, the height of the water flow over the notch needs to be between 2.4 inches and 15 inches. So these two on top of the hydraulic residence time, and the hydraulic residence time, or HRT, is the amount of time a volume of water stays in the wetland before leaving. And the researchers at Prado wanted 4 different HRTs for the wetlands of 6, 12, 18, 24 hours. So I designed 4 individual plates in accordance with these times. And as you can see below, the greater the HRT, which is the longer the water in the wetland stays in the wetland, the lower the flows, and hence the smaller the geometry of the V-notch. So these are the drawings I made for the individual plates, and I came up with them through a series of Excel calculations below using the volume of water in the wetlands, along with the equation provided by the U.S. Bureau of Reclamation's Water Measurement Manual, and the height of the water to produce the individual S and P measurements for each of the plates. So now these individual plates will slide into this box, and this is a prototype I made, medium density fiberboard 1/4-inch wood, and it also connects to we have a 6-inch PVC pipe connection, which connects to the current pipe in the current wetland. And hopefully this design, with water flowing through this notch and out the pipe, will allow for Prado researchers to better and more accurately measure water flow. Thank you guys for your time.